This is experiment 7, the voltage divider experiment. And then let's move to procedure session. Step number 1, we need to obtain these 4 resistors, R1, R2, R3, R4. Referring to the figure here, R1 all the way to R4, where R1 is a 330 ohm resistor that is orange, and brown. R2 is a 470 ohm resistor, yellow, purple, and brown. 680 ohm resistor, blue, gray, and brown, and then a 1 kilo ohm resistor, brown, black, red. Once we obtain the resistors, we need to measure each resistor's value using our multimeter. So measure this one, the number should be pretty close to that, same as 470, 680, and 1000 ohm resistors. We're gonna put the measured value per resistor over here. And these entries, we need to use voltage divider formula that we learned in the lecture to calculate that. And then here, these 4 entries, we need to measure each resistor's voltage, the voltage across every resistor. For example, after building the circuit, connect to the source, a 10-volt source, we want to know the voltage across R1 from one side to the other side across R1, that's V1. And then across R2, this is V2, this is V3, this is V4. Okay, let's do it. We need to connect the resistors in series as shown in this circuit first. I have already connected 4 resistors in series. As you can see, this one, the 330 ohm resistor, which is orange brown color resistor, connect here. The leg of the resistor connect to the leg of the other resistor. They connected on the holes that are in the same line, vertical line in this case. And the other side of this resistor, which is the 470 ohm resistor, connects to this 680 ohm resistor. There is a gap here, so the wire of that resistor and the other wire of the same resistor are not connected. Otherwise, we should not connect that this way. Because there is a gap, we can connect that across the gap. Both sides are not connected. And then for the last resistor with R3, they are also connected. The leg of this resistor, 680, and the leg of the last resistor, 1 kilo ohm resistor, connects to the holes, the 2 of the 5 holes in the same line. And then the other side connect to ground. This side connect to the power source positive terminal. In this case, we need to configure our power source to be 10 volts. First of all, let's measure the total resistance of the entire circuit. In other words, it's the circuit with 4 resistors connected in series. So let's turn on the digital multimeter. And as you can see, I already have the cable connected. We need to measure resistance, so the red probe connect to this port. Change here to resistor mode, and then set a range. The current range is about 20K. That means it can measure up to 20,000 ohm. So based on the resistance, adjust the range. This is a good range. So first I connect the red probe here, and then connect the black probe over there. Afterward, after connecting the cables, we should see a reading. The reading is 2.44. Since the range shows a K for the resistor, this is a 2.44 kilo ohm. So we are going to write it down. We're going to write it down over here. This is the total resistance of 4 resistors combined. Make sure also measure individual resistor value. Measure 330 ohm, 470, 680, 1000 ohm individually and record those resistance here. And then the next step, we need to configure our DC power supply. We need a 10 volt source. Therefore, we need to calibrate it. As you can see, so far I don't have the banana to banana cable. It's okay. If you have these cables, one that's alligator clips, the other one has the mini grabber, we can connect them this way. We can connect the wires, and then we can also connect these wires or the metal pieces, the alligator clip with the hook. However, we are not measuring resistance, we are measuring voltage. So change here to the voltage mode, turn on the source, but before turn this on, make sure the knob spin all the way to the minimum, 0 volts. Turn this on. And then we gradually adjust that knob to 10 volts, as indicated on the panel of the multimeter. Great. We get a perfect 10 volts. Now let's disconnect the source and the multimeter. We need to connect our source to the circuit. Now our resistor circuit received 10 volts. Our goal is to use our multimeter and measure those voltages and record them here. This is the voltage across resistor R1, R2, R3, and R4. Also the total resistance voltage. So let's do it. So first, I connect the red and the black probe to resistor R1. The red probe or the red grabber, mini grabber, connects to the resistor side closer to the source, which is there. The opposite side closer to the ground, so connect the black probe. And it receives a 1.32 volt. So I will write a 1.32 volt for resistor R1. And then do the same thing for other 3 resistors. We measure that here, this side closer to the source, the black probe connect closer to the ground. Second resistor, R2, receive a 1.88 volts, roughly. And then continue moving. The top branch, the top wire of the third resistor connect to the red probe. And then the lower wire of the third resistor closer to ground connect to the black probe of the multimeter. This one shows a 2.74 volts. So record the number. Let's move to the last resistor here. Follow the same logic, same procedure. The wire over here, the resistor leg over here closer to the source, and then the black probe connect to the wire closer to ground. Make sure it's connected. And we get a 4.04 volts here. So we have a 4.04 volts drops on resistor R4. Now we need to measure the total voltage, and the total voltage is measured from the beginning of the resistor circuit to the end, which is measure the source voltage, and that equal to 10 volts. In our case, there's a 10.01 volts. That's okay. Record everything you see exactly on the paper. This is 10.01 volt. Great. We complete step 3 and step 4. This is the second part of the experiments that require us to build a new circuit. We're showing in figure 3b using a 1 kilo ohm resistor. So if you flip to the other side of the potentiometer, this is a 1 kilo ohm potentiometer. And with R1 and R2, where R1 is a 330 ohm resistor and R2 is the 470 ohm resistor. We have a 330 ohm resistor R1 and then R2 equal to 470 ohm resistor. We add a potentiometer between the two resistors. So this is the top part, later connect to the power source. And then the power reached to this point. As you can see, they are connected in the holes along the same line. And then R1 connect to potentiometer, one side of it. The other side of the potentiometer connect to a second resistor, R2. And the opposite side of R2 connect to ground. This is the wire, this is the middle wire that connect to the shaft. And then I also add a jumper wire. The only reason I put a jumper wire here later for measure the voltage at this point easily. Okay, so great. We need to connect our circuit to the power source. For this circuit, we still use a 10 volt source. We don't need to change anything here. Just make sure to connect that to our circuit. So I put the wire here and then connect the red terminal and then also the ground terminal there. So if you start reading, the circuit shown in figure 3b, which is this circuit, the one we just built, use a 1 kilo ohm potentiometer and then R1, R2. To limit the range of voltages, assume Vs is still 10 volts. Use the voltage divider formula to compute the minimum and the maximum voltage available from the circuit. Construct the circuit we just did here, and then measure the minimum and the maximum output voltage. Okay, great. So we're gonna use our multimeter, make sure it's still in the voltage mode. Measure the voltage from the output. That is the center line of the potentiometer. In my circuit is the jumper here. Refer to ground. And the ground, as you can see, is there. So connect that wire here. Currently, with a unknown position of the potentiometer or a random position, we get a 6.36 volts. We want to know the minimum and the maximum. So what we need to do is just to spin it here all the way to one direction, get the minimum. The minimum in this case, here's disconnected. So I cannot spin it anymore on one direction. I pick counterclockwise direction. And the minimum voltage I can get at this terminal is 2.75, 2.74 volts. This is the minimum, 2.74 volts. And then record it to your instruction or the blank, the entry. We wanna spin the shaft to the opposite direction. So now let me spin this to clockwise direction, but all the way to the end until you cannot spin anymore. We get a maximum voltage of about 8.06 volts. So write it down. Put a 8.06 volts. This is the end of this experiment. The rest of the work we need to compute and verify our measurements.